I think is it over? Is it over all of you? Okay, from that table, anybody also stand up and tell me that what will be the answer for the question number 1? Anybody of you? Stand up and tell. Explain.
It also explain the existence of
If I ask you that what is the significance of azimuthal quantum number, can you give me the answer in one word or one sentence? Significance of azimuthal quantum number. Loudly, speak loudly.
existence of orbital.
Orbital, is it right? That is the electrical pathway. Okay, okay, come to the next question, question number 2. Okay, you just go to the board and solve it. Okay, solve it. Very good. Okay, it's okay. There is problems are becoming easy. Last slide, last slide, only last slide. Okay, I think all of you understand? Okay. Ready? Okay, now third question. What was the third question? What was the third question? Splitting of spectral lines in presence of magnetic field that we just discussed. I think all of you have the answer. Good. Now come to the most important part, that is the conceptual question. And who will explain the first question? Who will explain the first conceptual question? Determine the maximum number of electrons that can exist in a completely filled N5 level. How you can explain this? Go and do it. No problem. Go and do it. What will the answer? Do it. Okay, is it right, all of you? Can you explain it from the quantum number? From the quantum number, is it possible to explain? possible? N equal to 5. That means N equal to 0, 1, 3, 4. Okay? If 0, 1, 2, 3, 4, then each and every number have some m values. So it is very much complicated to explain from the quantum number. But is it possible to explain if it is n equal to 2? Now is it possible? n equal to 0, 1. 0 means S, P means A1 means P. S, how many electrons here? 2. P, maximum 6. So 6 plus 2, 8. And your rule, that is the 2n square. N equal to 2. So 2 into 4. But if n value is large, high, then it is very much difficult to explain. Okay? Here you can explain, but that will be more lengthy. Okay? That will be more lengthy. You can explain, but you have to take more steps. Okay? So that will be how? No, that you need to explain. Then n equal to 5. So 5, 25. So if it is right or wrong? If it is right or should you actually ask that question that is it right or wrong? If there is any problem regarding and according to Shukriyo that there is some drawback of that rule 2x square. Okay, so he asked the question. Okay, so that is your next reward. Okay, you will survey either if there is any drawback or not. Okay, and you have to respond me in the next class. That is your homework. Okay, now come to the next question. That give 4 possible quantum numbers for 5 electrons of the hydrogen atom. Anybody of you? Anybody of you from that table? Anybody of you come? Come. Anybody of you come, quick. Nobody? That table? Anybody of you? Come on. Go and write down. The 4 quantum numbers for 5 electrons. Okay, should you? Here electron is not written. Okay, so you have to show all the quantum numbers.
Here we say the 4 possible quantum numbers for 5 electrons.
4 possible means all the possible quantum, but each and every quantum number. Yeah, it's 2 months then.
Right.
You can do it by a table. You can do it by making a table. Yes or no? You can do it by making a table. If n equal to 5, so n will be 0, 1, 2, 3 and 4. So 0 is okay. A equal to here will be minus L, 0 plus minus 1, 0 plus 1 like only for 5. Okay. So it will be only for not 3. N equal to 3, 5 and 8. So 1, 2, 3, 4. So it will be equal to 0, 1, 2 and 3. So it will be 3. N equal to 3. Then N equal to write out. Okay, and okay, it's okay. But each and every case there will be plus or minus. For each and every case it will be plus or minus. Okay, okay. Is it over? Do you understand all of you? Okay. Now we move to the next question. Is it over? Any problem? Okay. So that part. Any question then? -3, -2, -1, 0, +1, +2, +3. Any confusion? Okay, so now explain the last question. Demand effect is related to the wave nature of the electron. Quick. Who will explain? Who will explain? You? Who will explain? What? Yeah. We can hypothetically you can write. Hypothetically you can write. There is no electron.
So that can be explained.
Yeah, exactly. That is hypothetical.
So that can be explained with the again example. If I am not in a house, then obviously my house.
Very good point. If you are not in the house, then already your house is there. That's why. Okay. Now we move to the next question. Demand effect is related to the wave nature of electron. Anybody of you? Can you explain? Demand effect is related to the wave nature of electron. Demand effect. What is the significance of magnetic quantum number? Demand effect is related to the magnetic quantum number. What is the significance of magnetic quantum number?
It shows the presence of orbital.
Orbital means which nature? That is the electron cloud. Which nature? Obviously wave nature. So you can't explain Demand effect without the wave nature of the electron. Because orbital is the wave nature of electron. Is it clear, all of you? Any doubt? Any doubt? Have you any doubt? Okay, so Demand effect, that is related to the magnetic quantum number? Yes or no? Magnetic quantum number gives us the idea about the orbital means wave nature of the electron. So that's what is related to the wave nature of the electron. Now is it clear, all of you? Okay, is it over? Now we'll move to the what I told you, that there is some very beautiful presentation made by few of the students. All of you made very good. Your response is very good. But one of the presentation I will show you. Okay, regarding that topic, I told you in the previous class that I gave you the topic and subtopic, and you made the class note and presentation PPT whatever. Then one student will explain the overall topic or summarize the second lecture. Okay, so should you please come? Okay, so just follow me. Team members of Subhyo.
Yes, sir.
Subhyo, well. Okay. So can you summarize the topic? Atom structure. Okay, so can you summarize the topic? Go. Please quick summarize the topic.
So, first we have Rutherford model. So, what Rutherford model describes that atoms are consist of electrons and protons, and it is mainly the protons. The nuclear charge are centralized in the nucleus, and electrons revolve around it in a circular orbit. And electrons can exist only, and the atoms size of the atom is very small, and most of the atom is vacant. Should go. So next there are some drawbacks of Rutherford model. So basically, according to Rutherford model, electrons continuously discharge energy. So if that is true, then there is a question about atomic stability, and we know that atom is stable. But according to Rutherford model, it could have been that electrons are jumped into the nucleus. So and after that, when we practically see according to Rutherford model, that could have been continuous structure. So that is the second drawback of Rutherford model, and the electron arrangement or electron configuration that Rutherford model can't explain. So after that we have the Bohr's model. So what Bohr's model says, Bohr model just rectifies half of the drawbacks of the Rutherford model, and Bohr's model states that electrons can occupy electrons can occupy orbits in which the electron's momentum is equal to nh by 2 pi, where n is the principal quantum number that was introduced by Bohr. So there are some drawbacks of Bohr's model too, and as you can see that Bohr's model can't explain the wave nature of electron. As we all know that the orbital exists, so the wave nature of electron exists, and Bohr model can't explain that. Although the atom is 3-dimensional, but according to Bohr's model it becomes 2-dimensional. So that is also a drawback of Bohr's model. And after that, Sommerfeld model.
Sommerfeld model, in Sommerfeld model, Sommerfeld introduced azimuthal quantum number, and it is denoted by L. He explained the fine structure of the spectrum. According to him, there are some electrical paths other than circular paths. So, azimuthal quantum number is range from 0 to n-1, and the concept of subset, that is SPDF, was by Sommerfeld model. Now there comes Zeeman effect. It is the effect of splitting a spectral line into several components in the presence of static magnetic fields. Zeeman also introduced the concept of magnetic quantum number denoted by M, and it ranges from -L to +L. Now there comes the Stark effect. It is the shifting and splitting of spectral lines in the presence of external electric field, and each electron spins around its axis, and the concept of spin quantum number, that is N, was introduced by Stark, and it ranges from the values are -1 and +1.
So here are some examples. Here are the chart of the all quantum numbers, that is principal quantum number, and there we say that there is azimuthal quantum number introduced by Sommerfeld, and here is subsidiary quantum number. So this is an alternative name for azimuthal quantum number. And after that we have magnetic quantum number introduced by Zeeman, and spin quantum number introduced by Stark effect. So that's all. Thank you.
Very good. Okay, well done. So you can conclude that chapter, that second lecture, by the significances of the 4 quantum numbers. We will repeat the significances of the 4 quantum number. Then I will discuss what will be done in the next class. Okay. So first quantum number. So the significances of the 4 quantum number, you will tell me. In principal quantum number, what is the significance? Orbit. Its azimuthal or subsidiary quantum number significance? Its magnetic quantum number? Spin quantum number? Electrons. Okay. Now I will discuss that what will be in the next class and what you will have to go in your home. This is the lesson for second lecture, and I will go to the lesson for the third lecture. So please all of you note down the code for the third lecture and join with that code. All of you please note down the code. Please note down all of you the code for the third lecture, and please note down it's MGBN. MGBN. All of you please note down the code MGBN. It is the code for the third lecture, and in the third lecture we will discuss about the So what you have to do is just that each and every class what you have done, that you have to make one class note. Okay? You have to make depending on that. You have to make a class note depending on that topic and subtopic from your book, internet, whatever. Okay? Then you have to upload in the brain space. Okay? Within 4 days. Within 20 seconds, I think. 22. Is it not? Within 22. So you have to upload within 20 seconds. Okay? March, and in 23rd March I will upload all my materials. Okay? Then you can read. Okay? So before that, within 4 days, you have to make the class note for all that topics. You have to read at first. You have to make the class note within 4 days. In the 5th day, I will upload in the brain space the materials for that topic. Then in the next class, we will discuss in the same method. Okay. Briefly, I will tell you what is the next topic. There are actually 4 principles you know that is the very important for the electronic configuration. There are some Moore's rule, there are some above principle, and there are some Pauli exclusion principle. Okay, so Pauli exclusion principle that is related to the quantum number. The 4 quantum number never be same. That is the Pauli exclusion principle. There is a huge application of the Pauli exclusion principle. And the above principle that depends on the either n plus l rule. N means principal quantum number and l means the azimuthal quantum number, either n plus l rule, or there is some rainfall method also. You can search in the internet or you do also what is the rainfall method. Otherwise I have discussed in the next class. And depending on that rainfall method or n plus l rule, there is some energy level, how energy increase for each and every orbital like 1h, 2h, 3h, etc. And depending on that, you can put the electrons in the particular subcell. Okay. And there is some Moore's rule also that depends on the pair of the electrons. Okay. How we will put the electrons in a particular orbital like p, then px, py, pz, and their applications. Okay. So that all that things we will discuss in the next class. But before that, what is the mandatory work? If any confusion or if any limitation, we will discuss in the next class. But you have to make the class note what you understand from your book or from your internet. What you understand, you have to make the class note. You have to upload on or before the 22 months. Okay. 22nd month. Okay. And 23rd month, you check in the same code in the brain space. I will upload all the materials, and then you have to read. Please, you have to read all the materials. Then we will discuss in the next class. Okay. So now, have you any doubt about it? Otherwise, we will close the class. Any doubt? Any doubt? Anything regarding this? No. So, if you have no doubt, then we will close the